Section 3.1 is an introduction to the coordinate plane, but you'll find that this really is just a review of what you learned a few years ago. So first, let's define what the coordinate plane is. The coordinate plane is a plane that is determined by a horizontal number line called the x-axis and a vertical number line called the y-axis intersecting at a point called the origin. Each point can be specified by an ordered pair. Given this definition, I have set up a coordinate plane for us to label and identify the different parts of the coordinate plane. First, they want us to identify the x-axis, then the y-axis, and then the origin. So let's do that first. According to the definition, the horizontal number line is called the x-axis. So horizontal is this one, so let's label it as the x-axis. Next, we'll label the y-axis. According to the definition, the vertical number line is the y-axis, so the vertical line is this one, so let's label that as the y-axis. Next, they want us to label the origin. The origin is the point that the two number lines intersect. So the point right here in the middle is called the origin. Next, we're also supposed to plot where a point that is positive would lie. So remember, if you go to the right, it's positive. If you go to the left, it's negative. If you go up, it's positive. If you go down, it's negative. So a positive point would go to the right and up. So in this area, all points would be positive. Next, they want us to label where a negative point would lie. So that if I go positive and then negative, all points in this area would be positive and negative. So a positive x value and a negative y value. Next, we have a negative point. So that means I'm going left and down. So in that area would be a negative, a negative x value and a negative y value. And finally, we have negative positive. So that means I'm going left and up. So all points in this area would be negative positive, meaning I have a negative x value and a positive y value. Next, a few more things about the coordinate plane. By the two number lines intersecting, it divides the coordinate plane into 4 different regions. Those 4 different regions have a certain name. So let's fill in the blanks here. A coordinate plane is divided into 4 regions called quadrants that are labeled using Roman numerals. And the way that you label the quadrants has to be done in a certain way. You start with quadrant 1 in the upper right hand corner in the positive area. So when we label these, this right here is quadrant 1, that's the Roman numeral for 1, and then you go counterclockwise. Counterclockwise means in the opposite direction of which the clock goes. So again, I'm starting in the upper right hand corner with quadrant 1, and I'm going to the left first for quadrant 2. So this would be quadrant 2, where the negative positive points would lie. Quadrant 3 would be where the negative points lie, and then quadrant 4 is where the positive negative points lie. Notice how I wrote 4 for the Roman numeral 4. It's an I with a V. A V, it means 5 with a Roman numeral. So the way I think of it as like 5 take away 1, and that's how I get the 4. Next, we're going to plot these points. So we have 0, 3, 1, negative 2, negative 3, negative 4, and negative 9, 0. Now remember, when you have ordered pairs, all ordered pairs are in this form. The x value comes first, and then the y value. Again, this should be a review. So when I see 0, 3, I know that my x value is 0 and my y value is 3, meaning I'm going to go 0 left or right. So I'm going to stay right there at the origin, and I'm going to go up 3. So start all of your ordered pairs starting out at the origin, and then you're either going to go left, right, up, down according to what your x and y values are. So again, since my x value is 0, I'm going to stay right here on the origin, and I'm just going to count up 3 units. So there's my point A. I went up 3 units. Next, I'll plot 1, negative 2. So that means my x value is 1 and my y value is negative 2. So that means I'm going to go to the right 1 and down 2. So starting here in the origin, I'm going to go right 1 and down 2. And there's my point B. Next, I will plot negative 3, negative 4. So my x value is negative 3 and my y value is negative 4. So that means I'm going to go to the left 3 and down 4. Remember, I'm starting in the origin. I'm going to count to the left 1, 2, 3, and down 4. 1, 2, 3, 4. And there's point C. Lastly, I'm going to plot negative 9, 0. So my x value is negative 9 and my y value is 0. So that means I'm going to go to the left 9 and then just stay there because my y value was 0. So again, I'm starting in the origin, and I will count to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to stay there since my y value was 0. And there's point D. And we also were supposed to name where each ended up, where each lies. So for part A with the 0, 3, I ended up on the y-axis. So my answer, instead of quadrant, I'm going to erase that part, and ended up being on the y-axis. And then for my point 1, negative 2, point B, it was in quadrant 4. And then part C, negative 3, negative 4, that's where letter C ended up. That was in quadrant 3. And my last point, negative 9, 0, didn't fall in a quadrant that time. It ended up on the x-axis. So my answer would be x-axis. Example number 1, give the coordinates of the points. So they give us a graph, and we are supposed to give the coordinates of point A right here and point B right here. So starting off with point A, I'm going to start in the origin, and I have to go to the left 2 and up 1. So my ordered pair would be negative 2 since I went to the left, and up 1, so positive 1. Next, for part B, I'm going to the right 1, 2, 3, 4, and down 1, 2. So I again start in the origin. I counted to the right 4, so my x value is 4, and my y value is negative 2 since I counted down 2 units. Now this next part is just a reminder. The domain are your possible x values, and range are your possible y values. And remember, for both, whenever you're listing the numbers for both, you always use the fancy parentheses, which are called braces. So again, domain is x, range is y. And we have to use this in our homework and also in the next couple examples. So remember, domain x, range y. Let's get to example number 2. Use the following equation to complete the table below. Y equals x plus 1. This is called a rule of 4 table. We are going to express this equation in 4 different ways. First as an equation, which we were given. Next as a verbal model. And then we'll express it numerically using this table. And we'll express it graphically using this graph. So the first part is easy. The way we're going to express y equals x plus 1 as an equation is just that. Y equals x plus 1. So verbally, we need to write this in mathematical terminology. So y equals x plus 1. Remember, is the same thing as equals in mathematical terminology. So notice how I'll write this. Y is the sum of x and 1. So maybe this isn't the most simple way to express this, but I just wanted to show you another example of something a little more higher level of how you can write y equals x plus 1 verbally. You could have also just said y is x plus 1 or x added to 1 or something like that. I just wanted to be a little more fancy with it and use the word sum instead of just being super basic about it. Next, let's fill out the numerical portion of this rule of 4 table. So we're going to complete this table of values with a domain of negative 2, negative 1, 0, 1, and 2. So remember, domain are your x values. So I'm going to fill in my x column with negative 2, negative 1, 0, 1, and 2. The equation was y equals x plus 1. This middle column is where we're going to do the work. We'll fill in the y column once we substitute these x values in for x in the equation. And then finally, we'll take our x value and our y value and write them as ordered pairs in the last column. So let's get to work. First, we'll substitute negative 2 in for x. So y equals negative 2 plus 1. Negative 2 plus 1 is negative 1 for my y value. So my ordered pair, negative 2, negative 1. Next, I have y equals, I'm going to substitute negative 1 in for x. So negative 1 plus 1, which is 0. So now I have negative 1, 0. Y equals 0 plus 1, substituting 0 in for x this time. 0 plus 1 is 1, so my ordered pair is 0, 1. Substitute 1 in this time, so 1 plus 1 is 2, 1, comma 2 for my ordered pair. And finally, let's plug in 2 for our x value. So y equals 2 plus 1, which is 3, so our ordered pair will be 2, comma 3. Now, we'll take this numerical portion of our rule of 4 table, where we came up with this set of ordered pairs, and we'll do the graphical portion of the rule of 4 table. The problem says graph the equation with the domain of -2, -1, 0, 1, and 2, which is exactly what I did for the numerical portion of the table. So we're just going to plot the points now. So let's get to it. So -2, -1 was our first ordered pair. So let's plot that. That means I'm going to go to the left 2 and down 1. So there's our point, to the left 2 and down 1. Next I have -1, 0. So that means I'm going to go to the left 1 and then just stay there since my y value is 0. And there's my point, -1, 0. Next I have 0, 1, so that means I'm going to stay right where I'm at when I start at the origin since my x value is 0, and then I will just go up 1 on the y-axis. And there I am, 0, 1. Next we have 1, 2, so that means I'm going to go to the right 1 and up 2. So I start in the origin, right 1, up 2. And there's my point. Last one, 2, 3, so I will go to the right 2 and up 3. And there's all 5 of my points. We do know this is a linear equation since the x value is just x to the first power and there's no other weird things going on in the equation like a square root or there's no fractions or anything where x would be in the denominator. So I do know again that this is a linear equation, so I can connect these with a straight line. So there's my straight line, or at least as straight as I could make it, going through all 5 points. I put arrows on my line because I know that this equation that I was given, it doesn't matter what x values I plug in, it's going to continue on this same trajectory the whole time. So I put the arrows indicating that's going to go on in that same pattern forever and ever. The last question is, what is the range of the equation? So remember, range are your y values, which we were given right here when we did the numerical part of the rule of 4 table. So I'm just going to list those 5 numbers, and remember, it's a set of numbers, so I'm going to use the braces. So I have -1, 0, 1, 2, and 3. Example number 3 is much like example number 2, just a different equation this time. And we're still going to do a rule of 4 table, just like we did in the last problem. But this time we're going to use the equation y equals -1/2 x plus 3. So remember, the first part is just to put this equation right here into the equation part of the rule of 4 table. So let's do that. We have y equals -1/2 x plus 3. Now for the verbal part. I'm going to get really fancy with it, so look at how I will write this. Y is the opposite of the sum of half of x and 3. Anytime you have just a negative sign, that's the same thing as you can say is the opposite of it. So I have the opposite of the sum, because I was adding, of half of x, because I was taking 1/2 times x. Remember, of in this case means multiplication, and 3, since I was adding the 1/2 x and 3. Now you might be asking yourself, are you expected to answer those problems like that with the fancy way that I did? Absolutely not. I just wanted to show you a more higher level thinking of how to write that. Let's move on to the numerical portion of the rule of 4 table. We're going to complete this table of values with the domain of -2, -1, 0, 1, and 2. So these are my x values. I'll put those in my first column for the x's. The equation I'm using is y equals -1/2 x plus 3. This middle column is where I'll do the work. I'll put my answer for the y values in this column, and I'll put them as ordered pairs in the last column. So let's get to work. Y equals -1/2 times -2 plus 3. A negative times a negative is a positive. Half of 2 is 1, so I have 1 plus 3, which is 4. So my ordered pair would be -2, positive 4. Next, put -1 in, so -1/2 times -1 plus 3. A negative times a negative is a positive. Half of 1 is a half, plus 3 would be 3.5. We'll just leave it as 3.5, since I'm just going to graph this later. So I don't need to leave it as a fraction or anything like that. So my ordered pair would be -1, 3.5. Next, let's put 0 in. So we have y equals -1/2 times 0 plus 3. Well, half of 0 is 0, so -half of 0 is still going to be 0. Plus 3 is 3. And so my ordered pair will be 0, 3. Next, put 1 in. So I have -1/2 times 1 plus 3. A negative times a positive is a negative. Half of 1 is a half. So I have basically just -1/2 here plus 3. That'd be like subtracting a half from 3. So that'd be positive 2.5. So my ordered pair would be 1, comma, 2.5. And my last ordered pair would be y equals negative 1/2 times positive 2 plus 3. A negative times a positive is a negative. Half of 2 is 1. So basically out of this I'm going to get negative 1 plus 3 be the same thing as 3 minus 1, which is 2. So my ordered pair would be 2, 2. Moving on to the graphical portion of the table, I'm going to graph the equation with the same domain, negative 2, negative 1, 0, 1, and 2. So I'm going to take my ordered pairs that I just found using the numerical portion of the table, and now I'm going to graph them on my graph. So first we have negative 2, negative 4. It means I'm going to go to the left 2 and up 4. There that goes. Next I have negative 1 and 3.5. So I'm going to go to the left 1 and up 3.5 units. So I'm just going to basically go between where 3 and 4 are at. So to the left 1, up 3.5 units. There we have it, negative 1, 3.5. Next I have 0, 3. So that means I'm going to stay where I'm at on the x-axis and just go up 3 units. There you go, there's 0, 3. Next I have 1, comma, 2.5, so I'm going to go to the right 1 and up 2.5 units. So basically I'm going to put a point between where 2 and 3 are at, since it's 2.5. So again, right 1, up 2.5. And there we have that one. And the last one, 2, comma, 2. So I'm going to go to the right 2 and up 2. And there we have all 5 points. I can connect all 5 of these points with a straight line, since I know this is a linear equation, since x is in the first power and that it's not in the denominator and it's not under a square root or have anything weird going on with the x value. So again, this is a linear equation, so I'm going to connect the points. So there's my straight line, and again, well, as the best as I can make my straight line, and again, I put arrows on it because I know if I continue outside of the domain that I was given, that this line would continue going on in this direction, in the same pattern, in this direction, in that same pattern. And just like before, our last question is, what is the range of the equation? This will be just your y values. It's a set of numbers, so we use the braces, and we typically write them from least to greatest. So I'm actually going to go backwards up my list of y values. So I'll start with 2, 2.5, 3, 3.5, and 4. That's it for this section. Make sure you write down any questions that you have so we can cover it before you're expected to do your homework in class, and we'll see you then.